Okay, in this video I'm going to be going over some dosage practice problems, and there are 5 problems on this page. I'm going to try and get through all of those in this video and then do page 2 in a separate video. Alright, so let's start with number 1, and in number 1 we are asked to find how many grams of stavudine should be given to a 150-pound patient. Okay, and there's a couple things I want to point out with this question right off the bat. The first thing is the dosage is given in terms of milligrams per kilogram, but the question is asking for grams. Okay, so already we see there's a difference in how the dosage is presented and what the question is asking for. Second thing I want to point out is that we're given the weight in terms of pounds and the dosage is in terms of kilograms, so we're going to have to do some conversions here. In general, with these types of problems, the first thing you're going to want to do is start with the patient's weight. So let's go ahead and write that out, 150 pounds. And then we're going to want to convert to kilograms. There's 2.2 pounds in 1 kilogram. I'm going to cancel my units out. That's how I know to put 2.2 pounds on the bottom, is because the pounds here are in the numerator on the top. Pounds here must go in the denominator to cancel out. I'm left with kilograms. Next thing I'm going to want to do is use this dosage. So for every 1 kilogram of patient weight, 1 milligram is dispensed. Okay? But I'm not finished here. If I stopped here, my answer would be milligrams, but I'm interested in grams. So I must convert milligrams into grams. There are 1,000 milligrams in 1 gram. Milligrams cancels out, and I'm left with grams. When I do this calculation on my calculator, I get 0.068 grams. Okay, what about a 225-pound patient? I'm going to do that the exact same way, except replace 150 with 225. I should expect to get a larger number of grams here. Again, 2.2 pounds, 1 kilogram. Same dosage, 1 milligram per 1 kilogram of patient weight. And 1,000 milligrams in 1 gram. And now when I do this in the calculator, I end up with 0.102. Okay? So this is a fairly straightforward problem. You're given the patient's body weight. You're given a dosage which is dependent on the patient's body weight. And you are asked to convert one into the other. But there's an extra step in this one, in that the question's asking for grams of medication, not milligrams. All right, moving on to the next problem, number 2. Tetracycline is used to mark polar bears without the use of sedatives or tranquilizers. If 25 milligrams per kilogram is an effective dose, how much tetracycline in grams is needed for a 1,000 kilogram bear? Okay, so what we need to notice right off the bat here is that we are given the dose again in terms of milligrams per kilogram, which is very typical. But the patient's weight, the bear's weight, right, is in terms of kilograms. So we don't have to convert like we did in the last problem. We are already in kilograms. So we're going to start there, 1,000 kilograms. Next step is to use the dosage here. The effective dosage is 25 milligrams for every 1 kilogram of body weight. I know to do this because I put the kilograms on the bottom to cancel out with the kilograms here in the numerator starting the problem. Once I do this, my units are milligrams, but I'm asked for this in terms of grams, so I need to convert, just like we did in the last problem, milligrams into grams. And once I do that, I'm finished. And the answer is going to be 25 grams. Okay, make sure to always put your unit in the answer. If you wanted to add an extra layer of detail, you would say the name of the medication, 25 grams of tetracycline. All right, number 3. Okay, this one's a little bit different because we have time thrown in there. We're still given a dosage, milligrams per kilogram, and we're given the patient's body weight. However, this tells us that this is the dosage for every 6 hours. So how much should we give in a 24-hour period? So first thing we can do off to the side here is divide 24 hours by 6 hours, and we get 4 doses in a day. Probably could have done that in your head, but just to show you, you're going to see where I use that here in a bit. Okay, and so start again with the patient's weight. 56 pounds. And we're going to convert to, you guessed it, kilograms. Next step, just like all the other problems, we're going to include the dosage here to cancel out the kilograms. 3.5 milligrams per kilogram. And what we can do here is say this is kilograms per dose. Milligrams per kilograms per dose. Okay? The reason why I can say that is because one dose covers 6 hours of time. You give one dose for every 6 hours. Okay? And so I incorporate this here, canceled out the kilograms. I'm interested in milligrams per day, and over here I did 4 doses per day. So I'm going to put that 4 up here to cancel out doses, and then that's per day. And when I do this, I end up with 356.3 milligrams per day. All right, number 4. In this problem, we have a concentration that we have to use in this problem. And there may be some unnecessary information here. So let's look at what we have. The tranquilizer Valium is sold in 2 milliliter syringes that contain 50 milligrams of the drug per 1 milliliter of liquid. And so I essentially spelled out this fraction, 50 milligrams per 1 milliliter, in this preceding part of the sentence. Okay, so these two things mean the same thing. 50 milligrams of the drug per 1 milliliter is the same as this. So it looks like a lot of numbers in this problem, but really this is the important bit. And this is this fraction spelled out. If 25 milligrams is prescribed, how many milliliters should the nurse administer to the patient? We don't really need this bit of information. The fact that it's sold in 2 milliliter syringes is not important for the math. It may be important for the nurse to know how many syringes need to be obtained, but it's not important for the math, how it's packaged. So this is a number that's really unnecessary for the problem. What we are interested in is this number and these two. Okay. We want to get milliliters in the final answer, and we're going to have to start with milligrams to get there. So 25.0 milligrams is what's prescribed, and the concentration of the liquid in the syringe is right here. In 1 milliliter of this liquid, 50 milligrams of the medication is dissolved. I know to put 50 on the bottom because it must cancel out. And I'm left with milliliters, which is what I'm interested in finding. So really this is just a one-step problem. Very simple. But there's a lot of words in there, and it may get confusing. So you've got to break down, kind of look at each number individually and figure out what you need for the problem and what the problem's asking you and what you can discard as unnecessary. All right, last problem on this page. A vial contains 25 milligrams per milliliter of a particular drug. To administer 15 milligrams of the drug, how many milliliters should be drawn from the vial? Similar problem as before. We're given the concentration. So in every 1 milliliter of this liquid, there are 25 milligrams dissolved. We don't want 25 milligrams. We only want 15. So we need to figure out how many milliliters do we draw out. We can expect that it's going to be less than 1 milliliter. Oops, I put the wrong unit here. And we need to put that 25 milligrams on the bottom to cancel out. Remember that, I didn't mention this before, but remember that when you see a fraction like this, where there's some number and some unit over just a unit without a number, you imply that there's a 1 there. Okay. When I do this, I end up with 0.6 milliliters. All right, continue with part 2, the back page on the next video.